Coming up on this episode of the IoT Inc. Business Show.
I don't see them as different, but analytics as a word and whole thing is a spectrum of different buckets where AI flows into it, ML platforms, the raw reporting, business intelligence, everything falls, and it's a whole spectrum from just looking at data to seeing why it happened, what could happen, and actually recommending what you should do, and also taking decisions if you really use rules along with prescriptive analytics.
Through its different techniques, machine learning allows us to look deep into our IoT data, giving us the hindsight, insight, and foresight we need to transform that data into useful information and ultimately value. But what's the mechanism to do that? In this episode of the IoT Show, I speak with Vish Pai about the relationship between ML and the IoT platform.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Vish Pai. Vish leads Samsung's ARTIK end-to-end IoT Cloud Platform as a Director of Product Management, managing product portfolios including cloud services, analytics, and applications. Vish also has over 10 years of working experience in Fortune 500 companies and growth stage startups. Vish, welcome to the show.
Thanks, Bruce. Thanks for having me on the show.
Now, remind me, was it my meetup that we first met, or where did we first meet?
We first met at the meetup.
It was the meetup.
And okay. Yeah, and then we followed up in a conference, and then we worked together on your book.
That's right. Yeah, that's right. So as everyone may remember, this goes back a little ways, but I had a number of reviewers going through each of the chapters, and Vish did a great job, and you're forever immortalized in the front pages of the book. You're right up
That's
there.
Right. That's right.
Now, how long have you been at Samsung?
I've been at Samsung for around 2 years, leading the IoT end-to-end cloud platform initiative.
Now, the cloud, you also as part of the bio, I mentioned analytics and applications. Is that, you consider that separate, or is that a subset of the cloud services?
Yeah, that's a great question. The way I have positioned the product and the solutions what we have at Samsung is to help customers grow and build the IoT business. Mm-hmm. And by that, what I mean is my goal and our goal at Samsung is to help them at every stage to launch a great IoT product, period. And whatever it takes from a platform perspective, be it giving them cloud services like device management, OTA, rules engine, etc., we provide them. But more and more in the last few quarters, we've seen them asking for more complete analytics, mm-hmm. tools, and more importantly, solutions. So that becomes, and there are some elements of it which will go in detail later, I'm sure, which can be immortalized or put it as part of the platform itself and provided as a feature to all customers. And that's how my involvement with ML tools and ML algorithms as part of my core cloud platform, the investment has increased. The number of features and products on those lines have increased a lot.
Mm-hmm. Now, remind me for ARTIK. Now, you're calling it an IoT Cloud Platform. Does that mean it's limited to the cloud? And or do you go into the IT and or the OT networks as well?
Oh, excellent question. At Samsung, the goal and the whole focus is to provide end-to-end tools and services for helping businesses get to market quicker and with the best products. We have all the things required on the way. When we mean end-to-end, it's truly end-to-end. Like, for example, some companies start at APIs and end at APIs, which is mainly a cloud platform. Other companies start with the hardware and end with APIs exposed by hardware. At Samsung ARTIK, we have the modules, and these are full system on chips with all the peripherals for edge modules, gateway modules, the software stack, which goes by the platform software, the cloud services, the networking and security stack, and also the reference applications on Android and iOS platform. So it's truly end-to-end, and I lead the cloud services and the embedded SDKs, which includes the ML services piece. There is another team which owns the hardware modules, and yet another which focuses on ecosystem and partners for the whole platform.
Okay. And then who owns then the embedded, the agent or the module? No, it would be the agent, the software that goes on the modules themselves right at the very edge on the embedded systems.
Right. That is partly me and partly another person, and the split is very straightforward. The way I look at it and the team looks at it is there are some components which go with the module. For example, the operating system, the drivers, and the libraries which are required for a module to boot up, run out of the box, and so on. So that goes as part of the module team. But there are some elements which are closely coupled with the cloud. For example, the networking, the onboarding stack, the device management, which is OTA management, which are very much coupled with the cloud services. That's what I own and I provide as part of my launch when I launch a new cloud service or ML algorithm as part of the core ML platform, and so on.
Okay. And, just speaking about the applications then, can they also run on can they run anywhere on the network fabric, or are they limited to the cloud? And also for analytics.
So the answer is mostly yes. They can run it on the cloud. They can run it on the edge, depending on the processing power and the memory provided. Yes.
Okay. All right. Yeah. So everyone listening, I mean, this is an important differentiation when shopping for an IoT platform, because, well, some IoT platforms will just be cloud. They'll just be the cloud itself. Some will go a little bit further and allow you to grab data on the IT part of the network. And what Vish is saying here is that in the case of ARTIK, and others, but in the case of ARTIK, also there is software that goes all the way to the embedded system, which is at the edge. The embedded system connects up to the sensors. It's going to have, and then it'll have a computing environment there. So it goes all the way in. So this is really important. And also when we get into, we will be touching on this as we get into the machine learning, the AI, as to where things run, where things are developed. But it's important when looking at your IoT platform to see how far it goes, because it's tough stuff. If it only goes to the IT, unless this is something very unique to your company, then getting it to go into the OT network is a bit of a challenge. So thanks for the explanation. Well, Vish, why don't you give us a little bit of background on your experience in ML, machine learning, and IoT?
Absolutely. So right now I work and lead the Samsung IoT initiative, but I started, like many of the product managers in this space, as a core developer in Qualcomm on software stack and protocols, and later in Amazon on the Kindle Ink and Kindle Fire as a full stack,
Okay.
Full stack embedded software and wireless software developer. That gave me a good insight into how devices work, because if you really think about it, Kindle e-ink, I'm not talking about the tablet or the laptop or phones in general, but the Kindle e-ink itself is an IoT device, because it is light, it connects all the time, it syncs books, it does all of it. So that was one of the first experiences in building protocols and having the 24/7 connectivity and all the challenges on embedded software. From that point on, I said, I moved on to a startup called Ayla Networks as a full stack cloud developer. A big jump, but that gave me a unique perspective on what happens on devices, what happens on the networking protocol stack when devices connect to the cloud, and also build and deploy services on the cloud. And at that point, we use AWS and other services. So it was a complete, full end-to-end technical exposure as a full stack, literally full stack developer, starting with embedded, then on the cloud, and also some applications. At that point of the career, I made a choice and moved to product management, because as you know, for a complete IoT product, you need to know all the three areas, which is the edge, or the embedded software piece and hardware, the cloud services, and also the end user facing applications, mostly mobile, but also web. So I had a unique experience having a strong technical background. So it was a natural transition for me to own the complete cloud platform. And that's the move I made in the startup. And from that point on, it's been launching products, be it in enterprise features, the analytics, and we'll touch more on it soon, as well as the core platform features for the IoT, and in general, it can be applicable to other fields too for the IoT products. Specifically in analytics and ML, I've launched many products, one of them being Ayla Insights as part of my role in Ayla, and I launched it in North America, Europe, as well as APAC. And that was a big launch with 30 plus analyst calls with the company leadership, especially working closely with the CEO and the CTO. That was my first big product launch in the analytics space. From that point on, I launched many ones, and the other big one, which was end of last year in Samsung, was the launch of ML for rules. And this is particularly huge because it fundamentally provides a way of not just analyzing, but having insights as part of anomaly detection, and also predicting outcomes for IoT specific use cases and many other products. But these were the couple of big launches in the analytics and ML space.
So this is interesting. So ML for rules, is that what you said?
Yeah.
So what does that mean, ML for rules? I mean, a rules engine generally does, well, you could call it analytics, right? I mean, it does do analytics. So is that what it is? It's kind of something that you can develop within the platform to do ML, or is it a little bit different?
Yeah, that's a great question. But I want to take a step back and explain what the significance of it and how important that is. And for that, what exactly does ML for rules entail? For that, we have in analytics like 4 phases. We have the descriptive analytics, the diagnostic, predictive, and prescriptive. And as most of you are aware of it, descriptive is what happened, diagnostic is why did it happen, predictive is what could happen, and prescriptive is what should we do. And what before ML for rules, what we had as offering for all our B2B customers was what happened and some form of why did it happen in terms of reporting tools and analytic dashboards. The important ask and the need of the hour was not just to know in beautiful dashboards and beautiful API calls where you can suck out all the data and have your own dashboard. The importance was to understand, is there something off for my data stream? And what will happen with, let's say, a room temperature or whatever that use case is? And so rather than offering a specific end use case solution for, let's say, a home use case or a factory robot use case, what I thought and the best way to do was embed as part of the core platform and provide that API not just for any action, but as part of a core rules engine so that it can be I would say 10 times more useful than just having a simple API call for your data stream. And the way it works is very straightforward. For every data stream, and when I say data stream, it is for a device, you have multiple attributes, and each attribute can be a data stream, or you can club multiple attributes as one data stream. So you can use that data stream as part of a if condition for a rule. For example, if the room temperature is going to be a number, let's say 75 degrees Fahrenheit in 1 hour or in 5 hours, then do certain actions right now. And this is very important because you can not only take that in the form of charting, but also use it to tie up with other devices. Like you can connect that external temperature detected or sensed by a device and do other actions for your house right way before what actually happens. And not just that, you can also use it to trigger other devices, but also other actions like emails, notification, push notifications, SMS, etc., etc.
Mm-hmm. Okay. No, I understand. And you were describing a pretty, typical rules engine. And generally, like you've kind of said, the rules engine, it's often also described as streaming analytics, where you're doing things on the fly. You can use it for data mining, which is kind of what you were talking about in terms of diagnostic. You can use it also for descriptive analytics, and this is kind of like, coloring things like dashboards. But where I was going with this is I've not seen it used for looking in the future. And that's where you start talking about, so the past and the present, that's what we just talked about. Yeah, yep. I've seen that. The future, though, for predictive and prescriptive, is it just a graphical user interface to basically manipulate, let's say, the hyperparameters of the analytics or the ML, or is it something different than that?
Right. All what we provide and all my products have typically three things. Or three big buckets. The first is the core engine as part of the platform, which integrates with all the other services as part of an event stream. The second one is, in this case, it was part of the rules, but it can be a direct API exposed. And that's where things get very interesting. Since this is a B2B business, we provide SDKs for all what we provide, so that customers can not only use our dashboards and have these cool as part of the rules, but also embed as part of their dashboards and their systems and integrate it seamlessly. Maybe it's mobile app, their own web dashboard, or IT systems. So typically a product has the core service, the APIs, the SDKs, and finally the reference apps.
Okay, and the reference apps. Yeah, and everyone, I'm kind of belaboring this point because the reason I asked Vish on the show is to start talking about artificial intelligence. As you'll see, it's going to be more machine learning, but how it's actually implemented. We've done a couple shows now on the theory behind it, what it's good at. And so this is going to be very important. So let's park this for just a few moments. And I want to just go up, let's go up a little bit. And I want to get your view on, and I've been asking all the guests this, but your view on what's the difference between AI and analytics from your point of view?
Yep, absolutely. Let's go on the definitions first, and then I can paint the whole spectrum, how I see the whole landscape. Analytics, or mostly called data analytics, is basically to examine the raw data, and you can have business intelligence, beautiful charts, graphs, reporting, and so on. Artificial intelligence, the whole goal of artificial intelligence is to get to do things which are human-like, and more importantly, the things which are associated with intelligence. like looking at objects, looking at understanding speech, making decisions based on the data which you know as a human. So making those decisions and being intelligent like humans. That's again, more of a raw definition, but that's what it is. Now, if you peel the onion and actually see what the analytics is, analytics actually spans across the spectrum. And as we saw in the previous question, analytics has 4 pieces. And to broadly, and I'll repeat that, which is descriptive, diagnostic, predictive, and prescriptive. And more importantly, the first 2, or the first one especially, is retrospective, which is looking in the back.
Right.
And diagnostic is mostly retrospective, but also looking into present, what's happening or what is happening right now. However, predictive and prescriptive are more future-looking, or to put it in other ways, all these 4 fall into hindsight, insight, and foresight. Just to rhyme it nicely.
I like that.
Yeah. So these 4 fall into these nice spectrum, what I call as my continuous analytics spectrum. And in this spectrum, everything fits into this, which is simple data analytics, BI intelligence, the reporting, the analytic dashboard, the predicting, the future recommendation, or you can call the ML platform implication, as well as AI kind of applications, because prescriptive, if you go on the higher end, is literally what humans would take decisions. It's actually prescripting it, but with rules, you can actually make those decisions too. So you can make decisions like human. So bottom line, the reason I'm putting this framework and the whole analysis is I don't see them as different, but analytics as a word and whole thing is a spectrum of different buckets where AI flows into it, ML platforms, the raw reporting, business intelligence, everything falls, and it's a whole spectrum from just looking at data to seeing why it happened, what could happen, and actually recommending what you should do, and also taking decisions if you really use rules along with prescriptive analytics.
Now, remind me, there's hindsight, then there's something, and there's insight. What was the second one again?
Yeah, so it's hindsight, insight, and foresight.
Oh, foresight. That's right. Okay. So, yeah, no, I like that. I mean, I think it is a spectrum. And what you're saying is that ML or AI is a subset of analytics, which I can buy. And I guess, when I first started digging into this, I was getting a bit confused because people were calling everything ML, or they were calling everything AI. And so let me try this on for size with you. I still like calling the analytical techniques, and this is just the basic analytical techniques, which are applying statistics, and so more like what you're saying, the hindsight and a little bit of the insight, so the descriptive and the diagnostic. I still think of those type of operations as being more analytics. It's when you get into the human intelligence or the human-like intelligence, the cognitive computing, so to speak, and when you start looking at the foresight, that's when I kind of start calling things AI, but in particular ML. And I kind of we've had this discussion actually before we actually got on this call, but it seems to me that ML really is the AI that we're talking about, and it is really different than analytics in the sense of it's a technique, it's a structure, it's a logical construct that then applies the analytics iteratively, recursively, and maybe conditionally based on what's going on. How does that does that make sense, or how do you want to fix that?
Yeah, absolutely. No, that's a great question. I've been having my the way I think about a problem is keep imagining and simulating. So I've been doing that for some time, and I like reading history, and I'm a big follower of history of technology and how it evolves. So looking at what has happened for the last 20, 30 years in this space, and to answer your specific question, is the definition of AI, and to stay to the core of it, is being human-like intelligence, and the part of human which is the intelligent part. So if you look at it in 90s or even 80s, people were building algorithms to beat a human in chess. And at some point, the algorithms were so good, except for the top, let's say, few people, the algorithms are better than most humans in playing chess. Now, would we call that AI or would we not? I don't want to answer that, but the question is very. Then it kept evolving, and more games got conquered by these algorithms, if you think about it. And finally, the epitome of that was Go, which is one of the games where people said, oh no, it will take another 10, 20 years at least for algorithms to beat the Go champion. But that happened a few years ago. So does that mean AI is better than all humans? Again, that's a question. An answer is obvious to us, which is no. Humans are much better because they can't do all the other things which we are doing. So then the question arises, so what are these algorithms good at? And is this truly AI, or what is it? So that's the question which we ponder upon. And the answer to that is, I think I found in one of the lectures by Andrew Ng, which is AI today is narrow AI, which is applied to a specific use case, and it solves it very well, and most of the time better than humans. And even today, even the voice and recognition of images, the algorithms are better than humans on an average basis. If you look at it, but still they're not there. And what he calls, or the industry calls, as general AI, and general AI is where the system or the whole algorithm, if you think of one algorithm or set of algorithms put together, is better than the overall human capacity of grabbing information and deducing insights and taking decisions based on that. And we are no way close to it, as we know, or at least as we generally know and available in public domain. So that, I believe, answers what you have been asking and your core question, which is, yes, there is AI, but it's very narrow for specific use cases. But what we think of AI and the core definition or the promise of AI is this general AI, and we are not yet there.
Yeah, and I think that's right. You've narrowed it down. You've narrowed it down to narrow AI, which is yeah, I definitely agree with that. And then within narrow AI, the reason you're focusing on ML is because that's the learning part. We can get into those definitions in a moment, but that's the learning part that allows you to be human-like intelligence in this very, very specific way, whether that is recognizing something, interpreting something, and which is a little bit different than, I would say, if we go back to your chess, your checkers, and then your Go analogy. The chess and the checkers were kind of more expert systems where it was really just looking at combinatorial, combinations, and then choosing the best. Whereas I believe, and you correct me if I'm wrong, when we got into Go, there was actually some learning that was happening, or was it still strictly an expert system for Go?
Yeah, you're absolutely right. Actually, the difference, again, if we're going a little bit into the more definitions, the supervised and unsupervised, and earlier, especially in chess, they just hard-coded if-else kind of rules.
Yeah.
And then they said, oh, no, we need to go a little better. So they did supervised, which is gave the algorithm a ton of data and based on the wins of past chess players, and it became better and better by learning these patterns. But Go, they started there, but I believe they went unsupervised, and the algorithm started playing with itself and got better and better at a rapid pace, which is very exciting from a technology perspective, but a very not so exciting, or challenges from a human and many other angles if you look at it.
And this kind of brings up another topic, and I just want a quick take from you. But there's an area of that's called explainable AI, and maybe do you feel comfortable maybe just taking us through explainable AI and what the issues are there?
Yeah, again, I'm not expert there, but the thing is, these systems, when they make a recommendation or a prediction or a solution, the logic, the chain of thought or chain of reasoning is lost because it just trains on this, in supervised case, a ton of data and spits out a decision or a coefficient, if you want to say, and then you make decisions. But in terms of explainable AI, in terms of how our legal systems are there or any other systems which are in place, you need to have a chain of reasoning why you did what you did. Otherwise, it can be seen as a bias against a human or discrimination. So explainable AI, and since this is AI, this by definition it's pretty complicated and not very simple for humans to get to these decisions. So there's AI built to actually explain the other AI decisions. It's pretty interesting.
Yeah. And originally it was a bit of a head scratcher for me because if you dig into it and you dig into, I think we're going to get into deep learning and so forth as a subset of machine learning, but it's all pretty much explainable. I mean, there's no hocus pocus or magic going on. Yeah, there's a lot of stuff going on. It's all in parallel. They call them these nodes and neural networks. But, assuming that you can have a constant seed for a random number generator, it should all be explainable. But what I've learned is that it's just, yes, but it's just so broad. It's so big and it's difficult to explain something, even though you can explain the actual calculations that happen. Originally, I was thinking, oh, they don't even know what happened. No, you know what happened. It's just because it's in parallel and there's so much data that it's working on individually. And like you said, these coefficients, they're changing the coefficients to improve things. It's just that it's a lot, right? I mean, and so that's interesting. This is the first time I've heard the concept of AI describing other AI. And I think what that means is AI taking a very complex problem and kind of maybe applying analytics to it, like clustering and so forth, to try to explain its phenomena. Is that your understanding, or is there something? Is it slightly different than what I'm thinking?
I think absolutely you're on the right track, and that's exactly people are exploring today because we know the advantages of narrow AI and ML for many use cases. But if you take those systems in businesses where there are people, there is money involved,
and there's regulations involved.
Yeah. So you need to explain them, and for that you need other systems now, which are again AI based.
Yeah, interesting. Well, why don't we talk about some of these use cases and maybe you can just give us an overview of, okay, so someone's listening right now, they have a business, and well, the first thing I'd be thinking about is, well, the AI sounds really cool, but is it something I can apply to my business? So Vish, can you give us maybe, just a high level on the areas that ML are good at? And if you can, with respect to IoT, if not, that's okay too. But just in broad strokes, what is ML good at? So machine learning good at, and maybe what isn't good at, or however you want to approach it.
Yeah, absolutely. And again, I have a good framework of visualizing and understanding the areas which are prominent and how to fit the current trends, which will give the maximum business impact for IoT and in general, the ML use cases. Okay. The first dimension in this is the verticals itself. In IoT or in any business technology impact in ML, it applies to different verticals like the consumer or home or security, all bundled under consumer. Yeah. Then you have the commercial or buildings or retail as a vertical of commercial. Then you have the industrial, which is very broad in itself, from anywhere from factory floors, robots to oil and gas use cases, industrial use cases. And there are other use cases for smart city, health, and so on. Yeah. Now it's important because each area is progressing at a different rate, and the application of ML and AI use cases are different. In fact, I have multiple products which are tailored for these different use cases. And the second important dimension before we dive into what areas are good for ML is the personas. Being a product manager, you need to think in personas, which is very important. The personas for these use cases. And typically, there are few personas which we all agree with, which is there's a champion or a business owner who has this technology. Maybe it's purely IoT with ML initiative. You have a bunch of developer personas on the embedded side, embedded developer, cloud developer, an application developer, and then you have the end customers who are actually using the end products, and they are a owner and a shared user. So typically you have 5 to 7 different personas across the value chain in an IoT use case or a B2B use case. So to summarize, we have the verticals, and we have the personas for each of these verticals, but we can boil them down to 5 to 7 core personas for any vertical.
Okay.
With that in mind, there is another important trend. What are the trends happening in ML and IoT? And the ones which are very relevant for business users today is the need for not just providing a general platform, but a solution for their specific use cases. And secondly, the trend of moving or having the analytics and the services not just in the cloud, but extending it to the edge analytics and edge computing, whole spectrum of computing. With all these, again, different dimension in mind, some of the areas which are very ripe, and this is a very important term in terms of market timing, some of the areas which are very ripe for disruption in terms of ML and AI technologies are in the consumer space and in the industrial space. And the solutions and products are very different in these two spaces, but the technology is there and the use cases will have a positive ROI for businesses ready to invest in it. For example, in the home use case, predicting and managing the energy bills is huge. At the same time, helping users have a convenience in terms of security, as well as simple use cases like lighting the walkways at night on their own without the user actually saying that. So these are the convenience and cost benefit use cases for the home, which the ML can help today. At the same time, on the industrial set of use cases, there's a huge ROI element in terms of if I even help run the factory for X amount of more time, that is, the downtime in factories are very costly. Even if I predict a part failure and replace it and reduce the downtime by, let's say, 5% or 10%, it translates into millions of dollars of saved or increase in the ROI. And for that, we have a lot of these algorithms to predict and detect in real time for the different factory parts and defects.
Okay, so like asset utilization, basically?
Absolutely.
Okay, so you're saying I want to go back to your framework. So I had verticals, I had personas, and were there a 3 and the 4? Was that the trends and I guess the computational space, or did I miss that, or is it just the 2 there?
Right. So there are 2 dimensions, and the third is to help you time the market. So, for example, the verticals and the personas are present in the past, will be there today, and will continue to be there. The trends are something which help you time the market in terms of should I do it today, or it should have already been done. That means I should go and buy, or should I wait for it and invest in the future? So those are the trends, and those are mainly specific solutions for use cases, the cloud to edge move, and also security and audit trails.
Okay. So what you're saying then, and this kind of meshes with my worldview, is that there's going to be specific, I don't know, let's call them, dashboard is not the right word, macro configurations for your analytics and your ML that's going to be for specific industries and for specific users of that ML or that analytics. And this is where it gets really specific, because if you talk about what we were talking about earlier in terms of the plumbing and that being the platform itself, that's pretty independent. That's pretty independent of industry. But when you get into it's interesting. There's two parts. There's the analytics and the ML that we're talking about now, and there's also the sensing, right? They can be very sophisticated right at the sensing component too. But those are the two mega components of the framework, is what you're saying. And then it's almost like like a Chinese menu in the sense of I guess a combinatorial menu of for this persona in this industry. Is it that you have like a configuration, you've got certain tools, and then for this persona in this industry, you got different ones? How do you kind of play out all the different, I guess, configurations for the framework?
That's a great question. And again, as soon as you look at it, and if you look at all these verticals, all these personas, it's not easy for one company to do all, and that's our strategy too, and that's in general what I've seen in the market, which is you focus on the platform because that's getting commoditized today. It's already been commoditized. So the plumbing is past, but the specialization is, can you help these use cases for these verticals and industries, and how can you help them? And for which personas can you help? And at the same time, build a rich set of ecosystem where you can work with partners who are domain experts for the specific verticals or use cases or areas, and that's how you address a bigger chunk of the market and capture that for your business.
Yeah, no, I agree with that. And then just to highlight again some of these specifics, then you were saying convenience and cost for let's say the consumer side. You're saying, and then predictive, I guess, asset utilization, but really what you're talking about is prediction for the industrial side. Are those the main buckets that you wanted to kind of highlight?
Yeah, absolutely. And I want to just bucket in two big areas, which is convenience and ROI. And convenience mostly falls in the consumer side and some in the commercial and industrial and other use cases. ROI is mostly applicable to businesses and the industrial use case where you invest X dollars and you have 5X or 10X or whatever that return you're expecting.
Yeah, and then for each industry, there'll be a different mechanism for this ROI. And I guess on the consumer side, there's a whole bunch of different convenience. And that leads us to a whole different podcast in terms of what people will pay for convenience on the consumer side, but let's not go there right now. Instead, what I'd like you to talk through is, okay, I want to, let's say that I do have an ROI. Let's say I'm in manufacturing and I do want to make sure that my $500,000 machine doesn't go down when I don't expect it to go down. Okay. So then what do I do? What are the tools? What is it if I want to implement ML, machine learning, in my company? What do I do? What is it? What is it that I'm actually using? Take us through that, and maybe on the authoring side, is there an authoring side, an executable side, but kind of take us through what it is that people purchase to be able to do artificial intelligence or specifically machine learning.
Yep, absolutely. And again, I'll go from a history angle to start with, which is what did people do before and what has changed today and how to get to that change. Okay. So what happened before, where there were analytics tools, and since analytics is a complete spectrum, this very much flows well into where it was and what people are expecting and doing today. The analytics was traditional BI and data warehouses, and it was very much system-centric for IT admins. And it was there for last 20 plus years. Mm-hmm. Then the expectation changed because the value was not just seen by the IT admins or system guys, but also by analysts in a company, as well as general industry analysts, and tools and systems went from being traditional BI and data warehousing to visualization based. And you have many of these very well-known companies who are in the visualization space. They were all analyst centric. So you had like awesome tools. You could embed any data stream, and you could mix and mash the data and have beautiful charts, outcomes, and decisions. However, other personas and other folks in the business start looking at this like, this is also applicable to us and not just the analyst, business analyst sitting in one of the teams. And that's how the move, and this is the move for the last 5 to 10 years, from being analyst-centric and system-centric to business user-centric. And here, these systems are intelligent, applicable to not just the developers, and we have a lot of good analytics for applications, be it Google or other analytics for developer-centric, but also for general business in terms of what's happening with the data, who's using it, who are using what features, when, why, and more importantly, very importantly, these are all real time, not delayed by a month or a week or even a day with these batch analytics. These are all real time systems for and which provide business user centric approach rather than system or analyst view. Now, with that concept in mind, what are the tools and how should one approach it? The approach is basically threefold. You need to start off thinking, how can I embed and put these tools and metrics and systems into my existing products and web interfaces or mobile applications, whatever those are. It has to be embedded, it has to be interlaced, and not a separate standalone thing which someone has to click and go. That adds to the complexity of it. That's number one. The second is it has to be narrative and has to flow with the whole product or service you're providing. And the third and very important is it has to be complete. You can't just stop at providing a dashboard with historic or hindsight kind of data, but you have to give them insights and more importantly, help them to make decisions, which is foresight. So you have to help them and cover the whole spectrum of analytics, which includes ML and AI, as we discussed before. So to summarize, the approach has to be embedded and interlaced, narrative, and flow with the whole user flows. And third, it has to be complete in the sense of providing them the hindsight, insight, and the foresight for their use cases. Very important. With that in mind, there are systems and frameworks you can start with. For example, I have worked with MXNet, Cafe2, but also there are other teams here who have worked with TensorFlow and all these general platforms and to get started and up and running for different use cases.
Okay, so and those what you're referring to are basically they're APIs that you incorporate as part of the you finish the blanks, but as part of the authoring component of basically the model building, or take us into a little bit more detail there.
Right. So when the ML tools are being used for a business and use case, there are two sets of people who are super important. One are the business or the product skills, and they're a little different here. And I'll double click on how they are different. And secondly, the engineering skills itself.
Yeah.
The product skills are different in the sense, in a typical product definition, I mean, this is general, there are variations in different companies and businesses, is basically you write a requirement and you have an acceptance criteria when the engineering develops and QAs it and the product or the business guy looks at it and you verify and you ship the product or release the product in an agile process. But for a ML use case or AI use case is different because the acceptance criteria or the inputs the product or business gives is in terms of these different data sets. You have to give a data set which says, hey, I want the end result to give me, for example, let's say I give X number of images, and you need to, at the end of it, find these are, this is a cat picture or a dog picture. It's different because initially you just wrote some requirements, but here you're giving sample data set for development as well as for acceptance criteria. So product skills are different. The second is engineering skills, which needs data scientists to identify the right algorithm and the right tool set. Secondly, the experts to build those systems. And finally, and most important, which many of them miss, is the domain experts. No matter no matter what you choose and how you build, if it's not relevant to the use case you're solving, it doesn't give you the ROI you're looking for a business.
Okay. So I'm understanding you're giving a really good description of the personas that are using the tools. Now I want you to switch into what are these tools? What exactly are the tools? Let's say for the two users, if it's going to be the business user that put together the requirements, is that it? That's their tool, is the requirements, or is there actually a dashboard that they use? So that's my first question. And then for the engineering side or the data scientist side or the domain expert side, what exactly are they doing? Are they programming? Are they using a point and click interface? Talk us through that. And in particular, I guess what I'm talking about right now is the model development, I suppose. Then I'm going to talk about I'm going to ask you about the executable in a moment.
Yeah, awesome. Let's take an example because I can walk you through how typically I have been and typically I've seen in the industry going through it. Mm-hmm. Let's say you want an algorithm that can learn and then predict for your data stream. Yep. That's your use case. And let's pick a very specific one. You want to predict the heart rate and see if there are any anomalies in it and learn from the past data for that specific user and predict. Mm-hmm. That's your use case. Okay. The product manager starts with the requirements, which is a set of data set, and then what is your tolerance and where do you think you are okay releasing this product to the market? What's your tolerance rate in terms of the positive use cases as well as negative? Mm-hmm. That's a general picture what you give your engineering team. The engineering team now has to go and decide on what is the algorithm that suits best for the problem. Mm-hmm. For example, you might go through the nearest neighbors algorithm, vector machines, Gaussian processes, mm-hmm. decision trees, random forest trees, etc., and obviously the famous one, neural networks. So you will go and run through for the requirements from the business or a product folk for all the algorithms as part of the suite. And we briefly touched upon some of these frameworks for these algorithms. Once you have decided, and the way you decide is you produce a benchmark of the prediction quality for the data set with all algorithms. This is super important. You're benchmarking the results of each of the algorithms, and I gave a sample set, including random forest, neural networks, for the sample data provided to you by the business and what you found out, and you benchmark against each one of them. Right. That's step number one. Step two is you measure the processing time to learn based on the data stream as well as to predict. For example, some algorithms might need 1,000 data points before they can reliably predict. Others might need 100. So there's a trade-off, but you need to choose and measure the processing time for learning and predicting for your algorithm and for your use case.
Mm-hmm. And the amount of data that you need, right?
Exactly. Okay. And that's directly correlated with the amount of data you need. So number of data points. Mm-hmm. The third important step is you evaluate the size of the model. Like you can deal with X amount of data or you need more amount of data, which is closely tied with what we just spoke and the previous step. Mm-hmm. And the last step is you need to, again, this is a business. You're not doing it for fun or nonprofit. You need to evaluate the cost of actually benchmarking, measuring, evaluating, and in runtime in the field, is this a profitable thing for your business in terms of learning and predicting and providing this solution to your customers? Okay. Once you walk through all of this, at that moment, you have a solution which you're ready to launch for the parameters and metrics you have defined at the start of the project, and then you deploy it.
Okay. All right. So effectively what you're saying is, and this is good, when we get into the model development. So just like analytics, AI, or in particular machine learning, it all works with developing a model. So the first step here is we need to develop a model. And what Vish is saying is, okay, well, we need to benchmark, each of the different techniques for developing a model. And you used a couple of them, the random forest, decision trees, clustering. I'm just making up a couple of these. So this is a good point from a business perspective, is to benchmark each of these for their accuracy. And then you need to determine, okay, well, how practical is this? How much data do we need? What's the computational time for our particular use case? And then what's the size of the model? And then last, which is often not talked about, is the cost. And when you say the cost of benchmarking and so forth, I'm assuming what you mean is going to be the cost of the equipment, the soft equipment, the hard equipment, and then the wet equipment, if we want to call humans the wetware. And then am I with you so far?
Just to add to the last piece, not just the cost of development, but also runtime.
Yes.
Once you deploy it
Absolutely.
in the field, does it still give you a positive NPV, or is it a better ROI?
Okay, so I like that. So I kind of think of it as an authoring step and then a runtime step. And the authoring step, you've taken us through it. Makes a lot of sense. So before we move on to the runtime step, because I'm going to be asking you, well, how do you incorporate the executable to interrogate these models within your product? But before I ask you that, for the authoring, how are we doing this authoring? We're basically using programming languages like Python and R and MATLAB, or are we using point and click interfaces, kind of like your rules engine? Talk to us a little bit about the authoring. What is it that what are we doing to create these models? What is it that we actually have to work with?
And when you say work with, is the end user?
No, the engineer. Yeah, the engineer here. So making the model, I mean.
Yeah. So the engineer has to go through multiple steps of, let's say you start. Again, we can go in very much detail, which is you load and do everything locally on your system or the laptop.
But is this done through programming, or is this done with an interface? How is this actually being done? I guess is really what I'm trying to understand.
There are both. There is programming where you go and run these individually, change it, tune it, add new coefficients. And also there is a new side of ML these days, up and coming auto ML, where this is done for you by these systems where it runs through multiple algorithms, benchmarks, evaluates, and gives you what is best for it. And then the domain expert can choose what suits best for their use cases.
Okay, so great. So in both those situations, then our output, unless I'm misunderstanding it, our output's going to be a model. It's going to be a cognitive model or an analytic model, but now we're talking about cognitive models for on the AI or the ML side. Then we have to do something with it, right, Vish? I mean, we got a beautiful model, but then how do we incorporate that model within what was the case that you used? Okay, you were using the heart rate data. So now let's say we've got a stethoscope, and it's an IoT stethoscope. Now, is this executing then in the cloud? And is this again another set of APIs that executes on that model that you developed? How is it incorporated within your product? And then, depending on where in the product you want to incorporate it.
No, excellent question. And that's exactly where the approach is super important. The approach always has to be, it's embedded. You don't see it as something exclusively ML. It just flows with your whole product. It has to be narrative where you make it very clear what is the outcome for you in this use case or the problem you're trying to solve. And it is I would say non-noticeable, but it is noticeable in terms of the wow it gives to the user. The way I have done it is provide the SDKs and APIs for technically adapt user to actually use it in their applications, but at the same time provide it in a way which is a service like ML for rules, where all the user of the system sees is, hey, I have this stream of data, and in this case, heart rate. I get anomalies and I get prediction. And then you can obviously use it to chart for past, present, and future, or you can give them recommendations, or you can take actions if the user chooses to use them in that way. And again, there's a whole plethora of ways you can do it, but the industry trend is to make it more click-through, where the user has to choose in plain English what this gives them or create rules or create these scenarios which are pre-canned for them in terms of templates, or give them choice of walking through them and making choices for their data and their use cases.
Okay, and what you're talking about there is more the UX as opposed to the back end, right? You're talking about how the users then would use the tool or use the product?
Yes, absolutely.
Okay. And then, so I think what you're saying then, yeah, it's the same. It's software. It's going to be, whether it's going to be an API or an SDK, what you're going to be doing is you're going to get a set of libraries, and you're going to be coding those libraries within whether that's going to be in the cloud, whether that's going to be on the gateway, whether that's going to be on the embedded system. You're going to be using compiling those libraries, so to speak, into your product, wherever that might be. And then you're going to be interrogating the model. And the model, well, by the way, we haven't talked about digital twin yet, but the model is going to be held, and this is just a data structure. We can use different terminology, but the model is going to be held within the digital twin that can be used in the application or can be used in the analytics. And so really, we're just talking about software. We're talking about software libraries, and what's very different here is going to be these models. Is there anything missing from that description?
No, I think this is perfect. The only addition I want to do is the new trend, cloud to the edge.
Yes.
And this is where you train in the cloud, and many a times you have to push it, let's say a .pml file to the gateway, and the gateway runs a train model. And again, this is through a simple OTA feature, but it's trained in the cloud, pushed to the edge, and the edge does ingest data, makes decisions, and if required, brings in a human to make decisions, and so on. So there's a add-on to it. There is a rich experience, as you rightly pointed out. You train it, expose it like any other software through APIs, SDKs, where the developer can embed in their experiences, or you provide it as an end experience. At the same time, there is another part to it where you can deploy these trained models to the edge, and then it can be then shipped or improved as we go with OTA and other services.
I like that. So you train it in the cloud. So another way of saying, well, you develop the model in the cloud, and then you deploy the trained model, which is an executable model, in the gateway, or even maybe in the somewhere else on the network fabric. Right. So it's kind of that's good to know this terminology. Well, Vish, this has been awesome. This is helpful, because AI in general, and then ML in particular, is still kind of fuzzy. And mostly it's fuzzy because I can tell you, when I started doing the research on it, when you're reading on the internet, there's not a lot of really good structured information out there. So this has been really helpful. Tell our listeners where they can find out more about you, and where they can find out more about Samsung's ML offering, and whatever you want to kind of leave us with now.
Yeah, absolutely. For Samsung offering, there are two core places. One is for the end-to-end system, hardware, software, and the cloud. You can go to ARTIK.io.
Okay.
And for the cloud-specific and the features which have launched, ML for rules and other anomaly detection algorithms, you can go to ARTIK.cloud, and I can send you the links, and you can put it in the show notes, and we can take it from there. About me and where can you find me? I think LinkedIn is the best. You can search me on LinkedIn for Vish Pai, or my full name, Vish Pai, and you're welcome to connect with me.
Excellent. All right. Well, Vish, I appreciate it. Great talking to you once again. And I think this is going to be really helpful to everyone listening. So we'll talk to you soon.
Yep. Thank you. Thanks for having me, and good luck.
Okay. That was a good talk with Vish Pai. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Tools and Frameworks for Applying AI in IoT with Curtis Sear. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be an insightful one.
You have been listening to the IoT Inc. Business Show.